We can also use the 45-45 90-degree triangle theorem to help us find the legs of a triangle when we know the hypothesis. So if you recall in the 45-45-90 triangle theorem, we can set up the sides of a 90-degree triangle, and let's first find where our hypothesis is. It's directly across from the right angle. And if each of the legs were to equal L, then the hypothesis is L times the square root of 2. Now, if that's true, we can set up a formula such as that the hypothesis is then equal to L square root of 2. And in this case, we know that the hypothesis is 5 times the square root of 2 in this triangle in 2a. And let's substitute x for L so that x then is equal to the square root of 2. And if we want to isolate the x, we can divide both sides of this equation by the square root of 2. So we'd have 5 times the square root of 2 over the square root of 2. That equals x. And here the 2's would cancel. Square root of 2's, would cancel. Each of the square root of 2's would cancel, and it would just leave us with x equals 5. Shazam. Now, in 2b, let's do the same thing. So if 18 were to equal x times the square root of 2, and to isolate the x, we divide both sides by 2. We got 18 over the square root of 2. But you may recall that it's considered ill-mannered to leave a radical in the denominator, and so we can rationalize this by multiplying this by the square root of 2 over 2, which then is going to equal 18 times the square root of 2 over square root of 2 times square root of 2 is 2. And then by simplifying this, we then can determine that the leg, or x, is going to equal 9 times the square root of 2. So each leg here is going to be 9 times the square root of 2 when we have a 45-45 90-degree triangle, and we know the length of the hypothesis. Isn't it wonderful?